We are doing capacitors. As you know, capacitance is a basic property of a conductor. Every conductor can hold electric charge on its surface. So capacitance C can be written as charge to the ratio of the potential raise. So I can write this Q as charge on conductor. Charge on conductor, the ratio of charge on conductor to that of the potential raise. The potential raise of that conductor. Potential raise of that conductor. In this manner, we are able to write the formula of electrical capacitance for a single conductor. When there are a combination of conductors, then you can write the same formula in this manner. That is charge on inner surface of high potential plate. High potential surface. Charge on inner surface of high potential surface divided by potential difference between the surfaces. Potential difference between the surfaces. This is when two conductors are placed symmetrically, then we take the electrical capacitance of that combination as charge upon potential difference. Which charge we need to take? Charge on inner surface of a high potential plate and charge on inner surface of a high potential plate are surface to that of potential difference between the two surfaces. Using this, we are able to calculate the potential difference. Now dear students, what we are going to learn today? Today we are going to discuss the parallel plate capacitor. Okay, previously we had between the two surfaces. Using this, we are able to calculate the potential difference. Now dear students, what we are going to learn today? Today we are going to discuss the parallel plate capacitor. Okay, previously we have seen combination of two concentric spherical conductors we have taken. Those two cases already we have seen in which how spherical conductors or conducting shells behave like capacitors that we have found. Now we are going to discuss parallel plate capacitor. Coming to parallel plate capacitor, if you remember this formula, we can consider a plate, a thin conducting plate. This is said to be a thin conducting plate. I call it as A and I give a charge to it, that is plus Q. When we give a charge plus Q to this conductor, as you know my dear friends, it will be distributed uniformly on either surfaces. So on these two surfaces, charge gets distributed uniformly like this. This is plus Q by 2, this is plus Q by 2. Here the charge density, if you observe, sigma is equals to Q upon 2A, actually Q by 2 upon A. The Q by 2 upon A, 2 will come into denominator. Similarly here the charge density sigma is Q upon 2A. So this is the charge density. Now it is having charge on its surface due to which it has acquired electric potential and electric potential energy. Now to add some more charge to this conductor, you need to reduce its potential so that you can add some more charge to it very easily. So आप और थोड़ा चार्ज इस पे अप्लाई करना चाहिए, तो आप क्या करना पड़ेगा, इसका पोटेंशियल को कम करना पड़ेगा. पोटेंशियल अपने आप कम नहीं होता है, इसीलिए हम क्या देखा प्रीवियस एग्जांपल्स स्फेरिकल कंडक्टिंग शेल्स के एग्जांपल्स में हम क्या किया, हमने दूसरा कंडक्टर को सिमेट्रिकली एडजस्ट किया. ओके, हियर आल्सो वी आर गोइंग टू टेक अनदर कंडक्टर. ओके, दिस इज कंडक्टर identical to A and placed or mounted parallel to A. So A and B are the two conductors which are identical. Now B has no charge. We are not giving any charge to B. B is a thin conductor which is identical to that of A. We are just placing very close to A, mounted parallel to A. Now between A and B there is air or free space, and A and B are very close enough so that in the electric field of A, because you can imagine some electric field lines like this. So this is said to be the electric field of A. In the electric field of A, you can feel that B is present. So automatically B is a conductor. So within B, whatever free electrons are there, because of induction, they come into the balcony and they start absorbing the positive charge because of attraction. So dear friends, here I can say that because of induction effect, the electrons will come on the nearer side. Electrons will come onto the nearer side like this. Okay, just like the people who ever come into their balconies and observe from the top of the buildings when some marriage procession is taking place, like that. Here negative charges will come very close to the positive charges and they are in attraction with the positive charge. So this negative charge we already previously called it as bound charge, and here the same amount of positive charge will be induced. So this induced charge is of magnitude Q by 2 and it will be having a charge density sigma is equals to Q by 2A. Okay, whereas this negative charge is minus Q by 2 and it is also having a charge density that is minus sigma is equals to minus Q by 2A. Like that the charge densities are present. Now dear students, if you consider with the knowledge of electrostatics, if you consider this as region 1, this as region 2, this as region 3, in region 1 and in region 3, if you consider 2 points M and N, and here how many surfaces are there? 2 plates are there with 4 surfaces. I call this as surface 1, I call this as surface 2, I call this as surface 3, I call this as surface 4. Okay, now dear students, surface 1, surface 2, surface 3 and surface 4, they are having charge densities already we have written. So surface 1 की वजह से at M we get electric field E1. Okay, E1 का magnitude मैं यहाँ लिख रहा हूँ. I am writing here. E1 has magnitude sigma upon 2 epsilon naught. Okay, the magnitude of E2 is also the same. E2 magnitude sigma upon 2 epsilon naught. Electric field because of a conducting surface. Okay, E3 is how much? It is also sigma by 2 epsilon naught. But E3 it is having negative charge on the third surface. So here I can write negative sign. But my dear students, here when you are writing the magnitudes, okay, sign is not important. Sign gives the direction. So I am not writing the sign. But you need to remember that the third surface has a negative charge. So the electric field is not in same direction like positive charges. Okay, here E4 is having sigma by 2 epsilon naught magnitude. Like this, we are able to write the magnitudes of the electric fields that are created by all the 4 surfaces. At M, E1, not only E1, but also E2, not only E2, but also E4, all the 3 are directed away, because electric field because of positive charge is directed away, whereas electric field because of negative charge, that is E3, that is directed towards the third surface. Now as you have seen the magnitudes, this E3 can get cancelled, and at this location only 2 electric fields will remain. The 2 electric fields will have a resultant electric field at M. So at M, resultant electric field, if you observe, that is sigma by 2 epsilon naught plus sigma by 2 epsilon naught, that is sigma by epsilon naught. This is net electric field where at M. Okay, this net electric field is directed in this direction. This is net electric field at M, that is directed away with how much magnitude? Sigma by 2 epsilon naught plus sigma by 2 epsilon naught. How much it is? Sigma by epsilon naught. The similar manner, if you think, here I am writing quickly. Okay, E1 directed away, E2 directed away, E4 directed away, whereas E3 directed inward. So at N, if you calculate the net electric field at N is how much? That is said to be having a magnitude sigma by 2 epsilon naught plus sigma by 2 epsilon naught, because the C3 may be cancelling with one of the E1 or E2 or E4. So 2 electric fields are remaining with magnitude sigma by 2 epsilon naught each. So net electric field at N is sigma by epsilon naught. So this is also directed away like this. So students, if you think carefully, the electric field in the region is extended up to infinity, whereas the electric field in the region 1 as well as region 3, they are extended up to infinity, whereas the electric field in the region 2 is strictly confined within the limited volume that is between surfaces 2 and 3. This electric field is remaining. So students, this region 3 or this region 1 cannot comprise a capacitor. Region 1 or region 3 cannot comprise a capacitor. What is the purpose of capacitor? To store large quantity of charge. What is the purpose of capacitor? To store large quantity of energy. Which energy? Electrical energy. Just like when we store water behind the dam, how can we use it for multiple purposes? Like that, if we store this electric charge on a capacitor, it can be useful so as to achieve so many actions in our electronic devices. See, in any electronic devices, nowadays you are observing everything slim, sleek models. For example, if you observe your mobile phone, it is very slim. You observe your LED screen in your home, that is very slim. You observe your computer monitor, it is very slim. You observe your iPad or any electronic device, they are all very slim in size, very small in size. But nowadays it is happening because of semiconductor devices. But some 10 years ago, 15 years ago, 20 years ago, if you think during the time of 2000s, we used to have very big televisions, we used to have very big electronic devices. Of course, in India, the mobile phones, the first generation mobile phones like Nokia 1100, Motorola phones, for them whatever chargers used to come, or whatever mobile handset used to come, that is like walkie-talkie, which is used by engineers, which is used by railway loco pilots. Walkie-talkie means a kind of a handset that is used for wireless operations. Such a walkie-talkie are very big in size, and if you use such walkie-talkies or such first generation mobiles, you may hit with those mobiles with anyone, they may lose their consciousness. Such type of heavy big mobile phones we used to have in our market, in our day-to-day life during 2000s. But within 20 years gap, there is a large change. There is a major drastic change in all the electronic devices. That is because of semiconductors. Okay, so without semiconductors, if you want to imagine an electronic circuit, in such electronic circuits, 3 building blocks are very common. So every electronic circuit or every electrical circuit will be comprising with the 3 building blocks plus a source. Source is, usually a cell or battery. Battery or cell will behave like a source of EMF. Okay. Now the remaining 3 are resistors, capacitors, and inductors. Resistors, capacitors, and inductors behave like building blocks. Suppose if you have a camera, ordinary Kodak film camera, if you have, in that flash will be there. Flash is a sudden light that will bring a glow onto your face, so that in the photograph you will be appearing very beautiful. Okay. So the beauty of the photography is dependent on flashlight. But inside the flashlight, what will be there? A filament will be there. And through that filament, large amount of charge need to discharge. Discharge means what? Need to flow. Okay, a large amount of charge when discharges suddenly through the filament of the flashlight, then flashlight glows all of a sudden. Okay, then of course the heroes or heroines are ugly, they appear to be very beautiful. So in this manner, flashlight works. But this flashlight need to charge very quickly, because not one photo now we take, multiple photos we take. So as to make multiple photos, we require quick charge and a quick discharge of the flashlight. So this can be achieved by using a capacitor. Not only that, a capacitor is useful. I told you, fan. Without fan, you cannot imagine your life. Of course, many people, without air conditioner also nowadays, they cannot imagine their life. So without fan, we cannot work. Of course, that fan also dependent on capacitor. So as to pump water from borewell to up, we require big capacitors. See, my dear friends, do you know this? In a project, water will be stored, and this water will be taken through the tunnels into the hydropower plants. Okay? So don't think that when water comes into dam, water will be filled behind the dam, and water will be released, then water will falling with a high speed, then turbines will rotate, then electricity will be generated. Don't think like that. If they do that, this water will go into downstream. So total water will go out of the dam. So they won't produce electricity like that. See, how do they produce electricity? In a dam, they store the water, and that water is taken through tunnels or through other channels into the power station. Again, that water is sent with a high pressure difference onto the turbines, with which turbines will be rotated, electricity will be generated, and using a little quantum of that electricity, again whatever water they have drawn from the project or a dam, again they pump that water into the dam. So again water will be stored in the dam. So in this manner, multiple times hydroelectricity will be generated. So in this generation and in this storage also, see, capacitors will function a lot. So capacitors are very, very useful in our day-to-day life. Now a capacitor is a device which stores large quantum of electric energy with a large quantum of energy density. Now tell me, my dear friends, in which region energy density is very high? Energy density is very high in this region. So in this region, energy density as it very high, this region behaves like a capacitor, not region 1 or region 3. So in region 2, there will be large amount of electric field energy density. Now here, what is the electric field intensity? That is sigma by 2 epsilon naught plus sigma by 2 epsilon naught. That is sigma by epsilon naught. See, you calculate here, you take some point P here, at point P, okay, E1 and E2 directed away like this. Not only E1 and E2, but also E3, it is also directed right side, whereas E4 directed left side. So anyway, E4 and E3 may be cancelled. So two electric fields will be remaining at point P. Okay, those two electric fields each of magnitude sigma by 2 epsilon naught. So what do you get here, my dear friends? Net electric field at P is nothing but sigma by epsilon naught. So students, for the sake of our convenience, let A and B are said to be separated at a distance D. Okay, now I would like to write here. Okay, that's why this region 3 I am erasing. Okay, now in region 2 at P, net electric field at P is how much? Sigma by epsilon naught. So dear students, when you get net electric field, you please imagine which type of electric field it is. The electric field is uniform electric field. So I would like to draw the figure of the uniform electric field, but I draw at the end. Okay, so the electric field between these two plates is uniform. Whenever uniform electric field is there, you can use EVD relation. That is potential difference between the plate A and the plate B. The potential difference between the plates A and B is V minus VB is equals to net electric field intensity, okay, between the plates into D. This is EVD relation. According to that, I can write here sigma D by epsilon naught. Dear students, please tell me what is sigma? Sigma is Q by 2A. So I would like to write over here this as Q by 2A epsilon naught into D. Okay, so here capacitance if you want capacitance, what is to be done? Capacitance is the charge on the inner surface of a high potential plate. Can you tell me which is having higher potential? This A can be having higher potential. So charge on the higher potential plate is Q by 2 divided by Q by 2 into D upon A epsilon naught. So this Q by 2 cut. So I can get capacitance C is equals to epsilon naught A by D. Okay, capacitance of this combination is how much? Epsilon naught A by D. I repeat, capacitance is the ratio of charge on inner surface of a high potential plate. This plate is a high potential plate. Charge on inner surface of high potential plate divided by potential difference between the two plates. What is the potential difference between the two plates? That I have calculated. So like this capacitance of parallel plate capacitor comes. Okay, now here how the electric field will be between these two plates. I want to show that electric field as I promised previously. So the electric field between these two plates I am writing now. See, the electric field between these two plates. Here is positive charge, here is positive charge, here is negative charge. Sorry, here is positive charge, here is a negative charge. This electric field is directed from positive to negative, and at the corners electric field is non-uniform. It is directed like this. Okay, at the corners electric field is non-uniform. We consider only that region which is uniform electric field region. We do not consider the electric field at the corners. Okay, this effect is called a fringing effect. So at the fringing effect, at these corners electric field is not uniform. It is non-uniform. Okay, the capacitance of parallel plate capacitor is C is equals to epsilon naught A by D. So capacitance C is dependent on surroundings, that is represented by epsilon naught. A is the area of each plate, and D is the separation between the plates. So it is very clear that the capacitance of a parallel plate capacitor or any conductor is independent of the presence of charge, but it is dependent purely on the surrounding medium as well as the dimensions of the conductor whatever you have taken. So in this manner, capacitance can be formed between two parallel plate conductors. Now our aim is to store more and more electric charge. So for that purpose, we can do in this manner. The scientists, what did they do here after calculating the capacitance of this parallel plate capacitor to increase the capacity of this? What they did, let us see. They have connected this conductor to ground. When they connect the conductor B to ground, automatically electrons start traveling from ground to B. So they neutralize each and every positive charge which is said to be free charge. Previously, we called this charge as free charge, whereas we called the negative charge as bound charge. The bound charge that remains like that only, whereas the free charge will get neutralized. When total free charge gets neutralized, here there will be no charge on the fourth surface of B. On fourth surface of B, there will be no charge. So third surface is having negative charge, second surface positive charge, and first surface positive charge. Now what happens? This negative charge on number 3 attracts the total positive charge inside. So I am erasing this electric field between B and A at the corners. Right? Now the total positive charge gets attracted by the negative charge. So positive charge will totally shift onto the second surface. Previously on second surface Q by 2 charge was there. Now total charge comes and settles on second surface. So there will be no charge present on the first surface. This happens because of strong attraction between the positive charge and negative charge present on second and third surfaces. Now if you observe carefully, on first surface there is no charge, and on second surface there is a total charge, that is capital Q, and the second surface has a charge density sigma is equals to Q by A. Now my dear friends, this total charge capital Q on A, it is situated on second surface itself. So on the first surface there is no charge, on the fourth surface there is no charge. Right? Now here, what is the charge present on B? It is minus Q by 2. Here plus Q. Okay. So previously what is the charge on number 3? Q by 2. So that minus Q by 2 will remain like that only. But here there is a lot of positive charge. So that this conductor B further gets electrostatic induction. Because a conductor at room temperature will have abundance of free electrons. So some more negative charge, okay, will come and gets induced, okay, opposite to the positive charge. So on 3 also, the total bound charge will become minus q by 2. Minus q by 2 to q. So total charge on the surface 3 will become minus q, and that much positive charge will get induced over here again. So whatever positive charge gets induced on the other side, because on B there are two surfaces 3 and 4. On 3 previously minus q by 2 is there. That plus q by 2 neutralized because of the electrons due to earth connection. Okay, now again on number 3 minus q by 2 gets induced. Are you getting my point? So total charge on second surface of A and third surface of B will become plus q and minus q respectively. Here minus q by 2 gets induced. Here plus q by 2 need to come. That plus q by 2 again gets neutralized. So what is the total charge on the surface 4 of B is 0. So what is the total charge on second surface of A? Q. On surface B minus q. On surface 3 of B minus q. Okay, so in this manner charge will be there. And here charge density on 3, if you observe, it is minus sigma is equals to minus q by 8. अगर आपको ये समझ में नहीं आया तो आप एक बार इलेक्ट्रोस्टैटिक्स का लेसन याद रखिए, आपको समझ में आएगा. ये अगर ये है, ये B है, okay, B connected to ground. If you refer your notes, you can understand this easily. If you give an electric charge Q to this and it is grounded, automatically here charge will be 0, here it will be Q, here it will be minus Q, here it will be 0. So this discussion already we made in electrostatics. So students, in that manner, electric charge will be distributed on the surfaces. So electric field is present only in the region 2 alone. In region 1 and 3 there is no electric field, there is no electric field energy or energy density. In region 1 and in region 2 electric field is 0, electric field energy densities are also 0. Here in region 1 and 3 no electric field, no energy density. In region 2 if you calculate, the electric field energy density is sigma by 2 epsilon naught plus sigma by 2 epsilon naught. Why? What is the reason? At this point P, the electric field because of 3, electric field because of 2, both are directed in the same direction, because positive charge की वजह से electric field है and electric field is towards the negative charge. Okay, so in this manner sigma by 2 epsilon naught plus sigma by 2 epsilon naught will give us sigma by epsilon naught. So students, this is the net electric field. If you want to write potential difference between the plates A and B, VA minus VB is how much? Electric field between A and B into D. So VA minus VB, if you want to write the potential difference between the plates A and B, is equals to electric field is sigma by epsilon naught into, that will become D. Sigma is nothing but Q by A. So you are able to write this as QD upon A epsilon naught. So that is the potential difference between the two plates. Now, if you want to write the capacitance for this arrangement, the capacitance of this arrangement is equal to C is equals to charge on high potential plate inner surface. Charge on high potential plate inner surface is Q. So Q upon potential difference between the two plates. Potential difference between the two plates is QD upon A epsilon naught. So dear students, if you calculate this capacitance, you are getting again C is equals to epsilon naught A by D. This is the beauty of the concept. So the capacitance, see, previously the arrangement is different. Okay, the conductor B is not connected to ground. Here conductor B is connected to ground. You may ask that, sir, for the previous one and for this one capacitance is same, no sir? Yes, the same. But here capacitance is epsilon naught A by D. In the previous case also capacitance epsilon naught A by D. But क्या difference आएगा? आपने जो charge दे रहे हैं कंडक्टर को, वो पूरा charge surface A पे inner surface पे आ रहा है. Previously this charge half Q by 2 here, Q by 2 here. Here minus Q by 2 here, plus Q by 2 here. Then charge density, energy density between the plates will be less. Here in this case energy density will be very high because total charge is participating in the capacitance. Previously यहाँ Q by 2 था, यहाँ Q by 2 था, यहाँ minus Q by 2 था, यहाँ plus Q by 2 था. So यहाँ electric field infinity तक है, यहाँ electric field infinity तक है. So energy density waste हो रहा है. अभी पूरा charge इसमें store हो रहा है. इसकी वजह से क्या हो सकता है? Energy density will be very high in this case than the previous case. In the previous case, between the two plates, energy density is less. Okay, in such a case, see what happens? This arrangement is said to be our PPC. PPC means parallel plate capacitor. So this parallel plate capacitor will be having capacitance epsilon naught A by D. Now immediately the doubt comes to you, sir, what is the energy density for this? Energy density you are telling high, and how much it is? The energy density, from there you are able to calculate the energy. So energy density is du by dV. What is this? This is said to be energy density. Energy density is having a formula du by dV is equals to half epsilon naught E square. This is the formula. Okay. Now from this you are able to write du. Du is equals to half epsilon naught E square. Between these two plates, what is the electric field? Sigma by epsilon naught. Okay, E square now, so it becomes a sigma by epsilon naught whole square into dV. So like this you are able to write. So on integration, beta integration of अगर आप किया तो energy du becomes integral du becomes u half constant epsilon naught constant sigma constant. Okay, epsilon naught square constant. So constants will come out. Integral dV will become what is the volume of this? That is the total volume. If you take the separation between these two plates d, okay, area of each plate a, then a into d is the total volume. You are going to get like that. So अगर आप इसको simplify किया तो आपको क्या मिलेगा? 1/2 epsilon naught sigma square का meaning क्या रहेगा? Q by a whole square. Okay, into ad. So ऐसे ही आप लिख सकते हो. अभी आप इसको सिंपलीफाई और करके देखिए, आपको पता चलेगा. U is equals to, here I am writing, U is equals to 1/2 epsilon naught. See here, Q square is there, 1a get cancelled. So in the numerator Q square, okay, D upon a. अभी आप देखिए, अभी आपको समझ में आएगा. यहाँ आप क्या देख रहे हो? ये epsilon naught D, epsilon naught a by D, epsilon naught a by D क्या है बेटा? कैपेसिटेंस होता है parallel plate capacitor. Okay, अभी बताइए D upon epsilon naught ये क्या हो सकता है? Epsilon naught a by D is C. So D upon epsilon naught ये बनेगा 1/c. So ये बनेगा U is equals to Q square by 2c. Q square by 2c is nothing but potential energy or the energy that is stored between these two plates. Are you getting beta? So इसको आप ऐसे भी लिख सकते हो. See this Q we know or we have C is equals to Q by V. Suppose V is the potential difference between these two plates. Suppose V is the potential difference between these two plates. Then C is equals to how much? Q by V. So instead of Q you can write here C square V square upon 2C. So U is equals to you can write here Q के बदले CV. Then Q square बनेगा C square V square. So ये फॉर्मूला क्या बनेगा? हाफ C V square बनेगा. Okay, formula for energy stored between the plates of the parallel plate capacitor you can write Q square by 2C or half CV square also you can use. अभी और आप सिंपलीफाई कर सकते हो बेटा. यहाँ V है ना, V के बदले अगर आप Q by C लिखा तो इसमें और सिंपलीफाई होगा आपको मिलेगा ये फार्मूला अगर आप यूज किया तो C के बदले नो यहाँ C है ना, C के बदले Q by V लिखिए तब एक भी कट हो जाएगा आपको मिलेगा half Q V. So this is also another formula for energy stored between the plates of the parallel plate capacitor. So a parallel plate capacitor okay is an arrangement of two identical conductors mounted parallel to each other with a small separation between them. Any medium or any other dielectric medium can be placed. Sir, dielectric medium कैसे sir? The electronic devices. That is because of semiconductors. Okay, so without the semiconductors, ये अभी आप देखिए half C V square बनेगा. Okay, आप formula for energy stored between the plates of the parallel plate capacitor you can write Q square by 2C और half C V square also you can use. अभी और आप सिंपलीफाई कर सकते हो बेटा. यहाँ V है ना, V के बदले अगर आप Q by C लिखा तो इसमें और सिंपलीफाई होगा आपको मिलेगा ये फार्मूला अगर आप यूज किया तो C के बदले नो यहाँ C है ना, C के बदले Q by V लिखिए तब एक भी कट हो जाएगा आपको मिलेगा half Q V. So this is